effectively powered by Apache Apex. So we'll wait for another couple of minutes for some more people to join. Today we are going to look at certain business cases of this particular application template, HDFS to HDFS sync. It's a single site sync from source HDFS to destination HDFS. So just give us a couple of more minutes to see if more people are joining, and then we'll start. In the meanwhile, if people could just point out whether I am audible, clear to everyone who has joined. Hello everyone. So just wanted to check again if everybody is able to hear me properly. If you could have some indications, then that would help. Okay, so I'm assuming that the voice is absolutely clear. So we'll move ahead with today's webinar. So what are we going to see today? So we start with an overview of our enterprise platform. So from DataTorrent called RTS, basically real-time streaming, which is powered by Apache Apex. So we'll take a look at the entire overview, what exactly is in there. We talk about this new concept that we've introduced as part of the recent release of the RTS 3.6. So it's called AppHub, basically an application hub. And then we look at this particular app template, HDFS sync. So from source HDFS to destination, new files and updated files get copied on a periodic basis. We look at certain use cases where this particular app template can be utilized in the industry as such. We then look at why exactly people should look at DataTorrent RTS. What are the features that it provides from an enterprise perspective? At the end, we can take some questions, and we have a couple of slides which talks about resources, certain links that you could actually go register yourself to get a lot of information. So moving forward, so if my screen is visible to everyone, so this is an overview of DataTorrent RTS. So if we look at the entire stack, so starting from the bottom, we really don't define that what kind of an environment you should have. So it could be a physical environment, it could be a virtual environment, it could be a cloud-based structure that you might have, the way it suits to a particular enterprise. What basically we look for is Hadoop 2.2 plus distribution. Any major distribution like Cloudera or Hortonworks, Pivotal, MapR, or even vanilla Hadoop is fine. What we basically need is the resourcing capabilities of Yarn. So the layer above Hadoop that you see, the streaming runtime, is our open source project Apache Apex, which is basically an in-memory distributed data processing which has got inbuilt fault tolerance, very highly performant. So the idea over here is to introduce this engine on top of Hadoop, which is mostly known for a batch kind of scenario, on a MapReduce kind of scenario. In this scenario, you can actually play your data in motion. So it could be data from a streaming perspective, For example, it could be a published API like Twitter. It could be something that you might have actually written, which is providing data at a certain rate, or it could be data at rest. So you might have staged the data in a particular store, in an operational store, and you want to actually utilize that data, process that data on top of this engine. So this processing of data happens in memory in a distributed manner. We'll shortly look at how it works. So on top of this is the other layer, which is Apache Malhar. It's basically a list of operators, what we call as operators, basically logical functions of any business logic that you could apply in an application. So things such as reading data from different sources such as HDFS or JDBC input store or any other file system that you could think of, or an API or from a socket, so forth, and then applying other kind of processing mechanism to it. So you could actually parse the data, you could enrich your data, transform your data, apply some more complex algorithms of your own as part of your own custom operator that you could add to Malhar or add to what we call as Apex application or streaming application. So the layer of streaming runtime, which is Apache Apex, and the layer above it, Apache Malhar, these two are open source, available in the ecosystem. You can download it through GitHub. The layer above, which is the visualization, the management console, and there is a graphical way of deploying what we call as the directed acyclic graph, is what is available as part of DataTorrent RTS, which is the enterprise version of this platform. So overall, the layers which are kind of blue in color is effectively what DataTorrent RTS is. And at the right hand side, you see a REST API, which is part of the offering as well. So that's the way how our platform actually integrates with any kind of existing application in the ecosystem as such. So in terms of Malhar, so let's look at what kind of operators are available. So this is the library which you would see at an Apache Malhar. So different kind of connectors that you will come across in terms of messaging, in terms of NoSQL or for RDBMSs. So it could be JDBC based, it could be a NoSQL for Cassandra or HBase. On a messaging side, it could be a client for Kafka cluster as such. On the file system side, parsers, transformations, dimensional computations, in-memory computations as such. So many of these operators, it's a list of like 300, 400 odd operators that are available. Quite a few of them are production deployable operators. You could just take these operators, package it into your Java application. So Apex has been written totally, Apex and these operators have totally been written in Java. So you could think of Apex as a single-threaded Java application, which basically utilizes these operators. So you could actually bundle these operators in an acyclic directed graph. So imagine one particular input operator. So let's say an HDFS input operator is actually reading data from the cluster and passing it on to, let's say, a parser. So the files might be in CSV format or a JSON format. You could actually parse, validate the data, and provide it for further enrichment, transformation, or any kind of business logic that you might want to apply on it. And ultimately write the data to the final store or any staging store in between. So this is what is available as part of Apache Malhar, all these operators as part of the library. And as part of our DataTorrent RTS 3.6, which is now available on our website, you could actually download it over there. There's a trial version for, I think, around 90 days. We've introduced the concept of AppHub. So these are application templates, as you could see over there. There are a few names mentioned over there. In our previous webinar, we had looked at Kafka to HDFS application, and in this one, we are going to look at the HDFS sync. So these are Java app packages. Basically, it requires Apex version 3.4. So our RTS is actually powered by Apex internally. So from RTS console as such, you can click on the AppHub and just click on the HDFS sync app template. So when I say template, what basically we are trying to say is, so these are ready-made Java app packages where a user just has to go and configure the properties for these operators that have been bundled in the template. You could download it from RTS, or you could actually go to our website at datatorrent.com. From there, these app templates are also downloadable. I'll just take the next slide and I'll take a few questions if there are any in between. So what exactly is this particular application template when we say HDFS sync? So in this, what is bundled is, so there is an HDFS input operator. So it's actually a file input operator as such. And on the right side, it's an HDFS, it's a file output operator, which writing to the destination Hadoop cluster, and it's pulling the data from the source Hadoop cluster. So what it is doing when we say sync, so on a regular interval, it's actually looking for new and updated files. As part of this version, we have provided these two. We would be working on the delete part as well in the newer version that would be available. So on a regular interval, on the configurable basis, it would actually read the new files and updated files from the source cluster. It could be any directory as such, and you could actually provide a regular expression with the kind of files that you would want to read. And then it keeps on writing on this regular basis as long as there's nothing wrong with your cluster and our Apex is running properly, or rather RTS is running properly on the Hadoop. It keeps on continuously writing to the destination cluster. Highly performant and as fast as a network bandwidth that you could provide. And internally, since it's powered by Apex, so there is built-in fault tolerance and scalability. I'll come to this last point when we talk about why DataTorrent RTS. So this just keeps on pulling this new and updated files on this periodical basis and keeps on writing to the destination Hadoop cluster. So if there are any questions as of now, I'll take some of them. Okay. Since there are no questions, I'll just move ahead. So coming back to the AppHub, so when we click on this particular template, application template, HDFS sync, so you'll actually get to this particular view where the description is provided. There are quite a few, couple of videos. There's a start video. There is another detailed video which actually tells how to utilize this application template in possibly a production scenario. So you could actually add more operators into this particular Java app package based on your need. If you would like to, other than just syncing the two clusters, or rather the destination with the source, if you would like to add something more to the data in between, you could do that as well. And there are documents available. There's a walkthrough video, as you could see in the snapshot as such. So the way to go about this application template is you could actually download this template on your cluster as such and deploy it over our platform, DataTorrent RTS, or you could actually take vanilla Apex from our Apache site and actually deploy this particular app template on Apex. So either way, whatever is suitable as per your need. So how would this be utilized, this particular template? So if you look at this particular snapshot, so you could have multiple, you could actually sync the destination cluster through multiple source clusters for each of the source cluster within, you could look at multiple directories and subdirectories, so forth. So you have to actually deploy an instance of this particular application for each of the source Hadoop cluster. So as you could see in this particular diagram, so sync 1 basically starts reading files from Hadoop cluster 1, and as per the configuration provided to this particular template, so it could read from multiple directories or a single directory, whatever is the configuration, and based on the regular expression, those files get continuously polled by this particular deployment on that particular destination Hadoop cluster. Similarly, you could have separate other instances of the same application template where it would read from, so it's a one-to-one mapping for each of the source clusters, and it will just keep on syncing the destination Hadoop cluster with these source clusters. So where would we normally use such a scenario? So if you look at data backup or archival, that's a very prominent scenario. So since Hadoop in a recent past is being looked upon as the new operational data warehouse or operational data store, so people are moving because of the things that are happening around the ecosystem and the total cost of ownership that Hadoop provides, uh, due to which many of, as I'm aware of, enterprise entities are moving from traditional storage to Hadoop as well. And many times for backup, they actually utilize Hadoop. So they have multiple clusters, so they need to copy data from one cluster to the other on a regular basis. So utilizing this particular app template, they could just deploy it on the destination cluster and it could easily sync with the source clusters if there are many. So for archival, for data replication, if somebody is building applications such as data retention or for disaster recovery, such kind of templates can easily be utilized for these applications. So where your input source is HDFS and the destination is also a Hadoop cluster as such. So why DataTorrent RTS? So first of all, the main reason behind RTS is Apache Apex. So our engine is basically internally Apache Apex, which is completely a native Hadoop engine with the entire processing is happening in memory. So all the operators that you saw in this particular snapshot of the operator library, they tend to process data in memory as and when they're getting data from the source as such. So we do not introduce any artificial latency as such while processing this data unless until the business logic itself introduces any latency, which might be provided by the developer as such. The reusable Malware components, so all the operator library components you could actually utilize from one application to the other. So one application that you build could easily be extended to build another application. Most of these operators are ready to go production deployable operators, so you may not have to add a lot of other business logic to it. You could just connect, pick and choose the operators that is applicable to your kind of application. So and it gives the flexibility to add custom logic, and you can build your own operator and add it to the application as such. The other main part is the built-in fault tolerance and scalability. So Apex ensures that if an application crashes, it would bring it back from the last checkpointed committed state of that particular application. So we have a concept of windowing, which has been discussed in the past in the deep dive sessions for Apex. There's a lot of material out on the web. You could actually look at that. So basically what happens is in this acyclic DAG, so let's say we are copying from HDFS and writing to HDFS, every time these operators would checkpoint the state of the data that is flowing in. And if there is a crash of the application, or let's say a certain node goes down in your cluster or something goes wrong with your cluster and the application goes down, it would bring it back. It would ask Yarn for new resources that way and redeploy the application and bring it back from the last committed checkpoint state, which has been maintained as part of the windowing concept, which is built in within Apex. And DataTorrent RTS is powered by Apex that way. In terms of scalability, these operators could be deployed. So as we said, it's a distributed in-memory processing. So it could be deployed on different nodes as such, based on your need, based on the data that is being thrown to this particular application. And accordingly, it scales out and scales in based on the velocity of the data that comes to this particular application. The ease of development which this particular engine provides. So all you have to do is have a Hadoop cluster in whatever environment you feel like. You just have to take these operators or build your own operator, which doesn't take a very long time because it's built in Java, so people are more flexible with that, and easily deploy it on top of Apex. So we have seen applications being deployed which normally would take like 6 to 8 months being done in like a month or so, and readily being tested on a pre-production or production environment. So that's how fast it is. So, and the support that you the development operational team would get from by joining our user forum on our dev at Apache. So you could post all kind of queries regarding your particular application. So imagine an ecosystem where the platform is readily available off the net as open source. The enterprise part, which is powered by it, is available for 3 months as an evaluation part. The connectors, or rather the operators which build the entire logic of the application, are readily available as part of the library, which you could reutilize with all the operational challenges of fault tolerance, of scalability, of low latency, of as high throughput as you desire, being already built in into the engine. This entire package is available to you at a shot, where you could just create this application within a few days' time and it's ready to be deployed. And it depends on the nature of your business need as to how complex or simple that application would be. So these are some of the sites that you could look at. So Apache Apex, our main site in the ecosystem. You could subscribe to these forums for Apex, and for DataTorrent, you could go to the Google groups. We regularly conduct meetups across the globe. You could actually, if you would like to hear from people, please do join our meetups. There are quite a few webinars that we conduct, as the one we are conducting today. And as part of this new offering that we have of application templates as part of AppHub, you could look at on our website, datatorrent.com/AppHub. Those who might be interested in utilizing this for their own product development or for their services, we have a startup accelerator package as well. So our definition of a startup is the revenue is less than 10 million USD with funding less than 30 to 50 million. If you fall in this, if your organization falls in this particular bracket, we provide the DataTorrent RTS free for a year as part of a startup license. However, it has to be deployed on a non-production environment. If anybody is interested, they can just go to this particular site or write to us. And we are hiring as well. So there's a lot happening within the ecosystem for Apache Apex. There's a lot happening at DataTorrent. And this is our current need. If anybody is interested, they can write to us at jobs@datatorrent.com. So we're looking at developers, architects. On the automation side, we're looking for the QA perspective, build and release. We're definitely looking at community leaders as well. Those who would be interested in contributing to our project, please subscribe to our Apache site and download through GitHub. And if you're comfortable, start contributing. We have 50 plus odd committers, mostly from DataTorrent and around our ecosystem in Apache, who have been contributing for a while, and the platform has grown leaps and bounds since it went open source. So in April this year, we became a top-level project, and there are a lot of integration that are happening with respect to the likes of Samoa, with Calcite. So there's a lot happening in terms of the ecosystem as such. And DataTorrent RTS is powered by Apache Apex. And the next webinar in this series of webinars will happen on November 23rd, which is a Wednesday. The local time, India time, it would be 7:30 p.m. So we would be actually deep diving into the same application template, HDFS to HDFS. This will be more of a technical session where our engineer would deep dive into the actual directed acyclic graph, talk about the operators that are involved in this particular application template, how it is deployed, how it utilizes the power of Apex as such. And this is happening on November 23rd. please do join us then. And thank you all for your time and for your patience to hear us out. If there are any questions at this point in time, I would like to take those questions.
So Mohit, there was one question which was trying to compare Spark streaming with Apex. So if you could give few points on that, it will be helpful.
So when we look at Spark streaming, the way it actually goes about processing data, so those are understood micro batches and their RDD structure. So the analogy that I could tell in terms of true streaming, so imagine a river is flowing and you have placed two sticks in the river, and the way that the sticks flow as part of the river. So that's how a true streaming happens. In terms of Spark streaming, so what they're doing is instead of flowing the data as a river, they're actually putting it in different buckets, and they have placed those buckets in an order. So that's a micro batch scenario. So in many scenarios that works out well for people, but it's not exactly a true streaming. So when we talk about Apex, it doesn't do micro batches. It is actually a true streaming engine where there's a concept of windowing. So which is either the event-based or system-based windowing that we provide in terms of time, where each of the operator that we've talked about. So here in this scenario, we talked about HDFS to HDFS. So it's reading the data as and when it's available. It's not batching it. It's not putting it into these buckets and then processing it. So, and this window moves as the data moves across the particular application. So this is the main difference, and in terms of state management, in terms of the checkpointing that we do, and there are some other details that you could actually look at on our website, DataTorrent.com. There is a data sheet over there which gives the entire comparison. But from a true streaming application, I would say Apex is a true streaming engine when compared to Spark or Spark streaming. Any other question? If there are any other questions, I would like to take them now. So there is a panel where you could actually type in your questions. If there are any questions from the audience, we would love to take them now. Well, once again, I would like to thank everyone for their time and patience. Okay, I believe there's a question.
So the question is about quality of service profiles and max latency allowed and so on. So how will you compare Apache Apex with Spark on these terms?
So as I mentioned, so there is a data sheet on our site which provides a. So we have looked at it more from a functional basis. We have not gone and tested out or benchmarked it where we have actually benchmarked for these features as such. But based on the inputs that we received from our customers, from the prospects who tried out Spark streaming, again, it's a project in the ecosystem as such, which has a different way of looking at and processing data. That's how it matters. And those who are more inclined towards batch kind of a scenario, Spark is obviously an option for them. In Apex, which is a true streaming platform, we look at batch as a subset of streaming. So you could actually play data as per your desired interval. That's how we look at it. Now, in terms of latency and all, definitely whoever has tried Apex, so there is one of our clients, Capital One. They have shared, they've done a meetup and they have shared their results on SlideShow on the net. So they did try out, I think, Spark as well. Their demand was to run an application with 3 copies of the application, where they were doing some risk analysis for each of the transaction records that was going through the application, and their requirement was 99.99 uptime with lower double-digit milliseconds in terms of latency. With Apex, they, on an average, they got less than 2 milliseconds, which could not be achieved by any other platform as per their own analysis. So that's all I would have to say about Spark streaming. So in these sessions, we cannot really do a one-to-one comparison for these numbers. There has to be a more detailed testing that needs to be done in probably a lab environment where you run the same application on both. But it also depends on what that application is and how somebody is looking at that particular application. So once again, I would like to thank the audience for taking out your time and attending this particular session. We have the next session, next webinar on November 23rd, where we'll be deep diving into this particular application template. So those who are very keen on looking at what exactly happens when we pull data on a regular basis and write to the destination cluster and ensure that it's synced with the source, please do attend that particular session, Wednesday, November 23rd. Thank you.